Okay, thanks for joining us. My name is Josh Oreno. I'm from Security Compass, and I'm joined by Stephen Patterson, senior consultant on our advisory team, our security consultant team here at Security Compass. Today, we're going to be talking about a book that he recently published called Building C2 Implants in C++. It's an ebook. It's free to get, and we'll have a link to the Get Book link in the description so you can download your own copy. Stephen, tell us a little bit more about who you are.
Yeah, so I'm Stephen. I started working in game design in Montreal for an indie studio. We were developing a game on cybersecurity. So that's kind of how I first got pretty seriously interested in this field, and decided that it was something that I wanted to pursue. So I basically took a year to do independent research. I started a blog and started publishing tutorials on Windows exploit development there, and started getting more involved with the community, doing my own research and pursuing fuzzing and things like that. And then eventually someone from Security Compass reached out to me, whose name is Jackson, and said, hey, I'm interested in Windows exploit development as well. And just kind of started that conversation. And then that's how I got my start at Security Compass. And I've been working at Security Compass for a little over 3 years now as a consultant. And lately I've been pretty interested in red team tooling, specifically command and control software. And kind of noticed there was a lack of resources for developing an implant in C++. So that was my project last year, and decided to publish a book about the topic.
Seems to make sense. But why take the leap in going from, sure, you moved into security as your, sole focus of, what you're working on in your career, and then kind of building on those passions, bringing in some of the capabilities you learned and applying towards red team. Why make the leap in actually writing a book about it?
It was primarily because I saw that gap in the fact that a lot of the implants were being written in languages like PowerShell or C#, and there were relatively few written in C++. So I wanted to contribute something that would help others in that area, and also try to make that material a little more accessible as well. I first started learning about this subject from a talk given by Josh Oreno, which was called C++ for Hackers. And so I just kind of wanted to build on that and try to share something with others that people could use to get started in this area. And also I just wanted to have a project where I could apply my own skills to, because I'm currently learning C++. And so this was a good way to kind of keep myself on track and something to keep applying something to.
Yeah, that makes sense. I can see how that'd be beneficial as you're kind of going through your own learning journey and applying it. Writing the book really helps to solidify that knowledge. But why is this relevant to anybody else other than Stephen Patterson?
I think it's primarily relevant because there's a lot of people in red teams right now who have been using off-the-shelf stuff or open source tooling like Cobalt Strike or Covenant, and becoming more interested in how that tooling works at an underlying level, and want to build something in-house to complement that stuff. Also, I think that there's just a lot of people building C2s right now and sharing that. So I think that there's a lot of people out there now who have become interested in that area and might want to try contributing something of their own.
It kind of matches your history, as you're talking earlier about your community involvement and how you met Jackson, how you came to be here. So that's pretty consistent with the whole time. So, okay, with that in mind, just kind of taking it a step further, like why C++? You mentioned PowerShell and you mentioned other kind of platforms that people use. Why did you select C++?
I think that there's a couple different advantages to building an implant in C++ as opposed to something like C#. Some of them are related to stealth. So there's more and more AV and EDR products that have visibility into implants that are written in C# or PowerShell. For example, AMZ is one of those. So C++ has that advantage. So it's just a little more likely to be undetected by those products. Another aspect of C++ that is good for implants is that it's relatively straightforward to reverse engineer something that's written in PowerShell or something that's written in C#. So there's a little more difficulty into reverse engineering something like that. And just for myself, I am trying to get better at C++, and this is a great practical project just for me to practice those skills and get better at that.
It makes sense. Like if the goal is to make a better implant, something that's more stealthy and more effective, seems like C++ is the way to go. With that in mind, and keeping in mind like the audience of your book, is it really for kind of really active practitioners? Is it approachable for people that are just kind of getting into red teaming? And will they need a strong foundation in C++? Can you give us some kind of indication as to who this book is really for?
Yeah, sure. So I primarily wrote this for beginners. You don't need to be an expert at implant development or be intimately familiar with the frameworks that are available right now. And all the code is pretty heavily commented as well. So you also don't need a ton of C++ experience because I try to include a lot of comments for each block, so you know what's going on. You should just have some basic familiarity with software development in general, and I think you'd be able to get through this book. So yeah, primarily aimed at people starting out or just generally interested in this area.
Speaking from more of a practical perspective, for people that are actively doing red teams, whether it's like in-house in an organization or as a consulting capacity like you are, why do this? It seems like there's a lot of work that would go into kind of writing your own C2 framework from scratch. Obviously, lots of time, lots of thought that needs to go into it. How does this benefit a red team to have custom C2 implants?
One of the benefits of making your own product in-house is that it's something that's not going to be signatured by AV or EDR vendors. So that's one of the big benefits is stuff like Cobalt Strike or open source software generally going to be pretty well known to those vendors. And so you're going to have to put in a little more time and effort to make sure that it's going undetected, that it's unsignatured. So just baked in, you have that the fact that it's not going to be signatured by those vendors. So yeah, that's the prime benefit. And another reason is that you can demonstrate to the blue team how their defenses would stack up against something that is not signatured, that is custom malware, and you can emulate those groups out there that are using their own custom malware and kind of gauge how those defenses are going to stack up against something like that. So yeah, there's a couple of reasons why you would want to invest the time to have your own in-house product to complement your off-the-shelf tooling that you might already be using.
Yeah, that makes a lot of sense, right? Like if the whole point of doing red team is to test your preventive, detective, and response capabilities to real world adversaries, real world threat actors, real world scenarios, it's not to test your blue team's capability to detect off the shelf tooling, which I think sometimes it can kind of twist into. So this will definitely see stronger development of capabilities. I can see that in using the strongest C2 implants. Makes a lot of sense. Thanks. So what's next for you? Now that you've completed this book, it's published, and you're obviously continuing as a red team, consultant and doing a lot of other different things. What's your interest right now? What's next for you?
Yeah, so right now I want to make a part two to this book that explores some more advanced components of C2 and builds off of the basic implant that's built in the first part. So I'm pretty interested in looking at what C2 frameworks are doing with regards to evasion and anti-reverse engineering, looking at how people are approaching obfuscation uh, and protecting their communication traffic with the implant. So looking at how to approach encryption, things like that. So yeah, those are the areas I'm focusing on now. There's a lot of really interesting stuff coming out in regards to evasion. Like there's tooling that's implementing like direct syscalls now as a way to evade EDRs, and some pretty interesting projects out there that are incorporating that capability. So yeah, that's one particular area I'm interested in right now, and trying to research a little more this year.
That's great. Thanks for sharing, and thanks for joining us today, learning about the book that you wrote and why you wrote it and your personal journey. All very fascinating. Um, Again, we'll have a link in the description so that everybody can get this free ebook. And thank you very much.
Yeah, thanks for putting this together.
Have a great day.
Yeah, you too.